Hello, Room 10. I wanted to give a very brief demonstration of mixed numbers and improper fractions. Rather than doing a few problems for you, I thought I'd show something that we did in class together as a demonstration and just talk you through some of the steps. A mixed number and improper fraction both represent when you have more than one whole, somewhere between 1 and 2, or a little more than 4 but not quite 5. You can represent these two different ways, either a mixed number, which is a combination of a whole number and a fraction, or an improper fraction, where the numerator is larger than the denominator. If you look at the left side here, you can see there are 4 squares drawn, and each square is divided up into fourths, 4 equal parts. These first 3 are colored in completely and represented here by our 3 holes. This last square is divided up into fourths as well, and only one of the 4 pieces is colored in. So this mixed number, when you put it together, you take the number of whole squares that are colored in, 3, and the fraction that's represented by the one whole that is not colored in, 1/4, and you have 3 and 1/4. This demonstration down here with the circles shows 2 complete circles and 2/3 of the remaining circle, and is read 2 and 2/3. So slightly more than 2 complete circles, but less than 3. Last but not least, we have one whole rectangle here divided up into fifths, and another rectangle divided up into fifths with only 3 parts colored in. So the one whole is represented here, and the 3/5 of the remaining rectangle is represented here, and we read this as 1 3/5. Now sometimes it's advantageous to write these mixed numbers as improper fractions, and we have a very easy trick which some call the circle thingy. You take the denominator, you multiply it by the whole number, 4 times 3 gets 12. You add that 12 to the numerator, 13, and the denominator always stays the same. It always stays the same because the size of the pieces are never changing. You can see these 13/4 over here if you look at the drawing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And each one is a fourth. Looking at our next one, 2 and 2/3, we take our denominator, 3, multiply it by 2, get 6, add 2 more and get 8, and as I said before, the denominator stays the same. We can also count those 8/3 over here, 1, 2, 3, 4, 5, 6, 7, 8/3. Last but not least, we take the denominator 5, we multiply it by 1, add it to 3, and get 8. And we're dealing with fifths here, so it becomes 8/5. 1, 2, 3, 4, 5, 6, 7, 8. I might start another video to show you how to convert from improper fractions back to mixed numbers. But one hint would be that this line right here means division. So basically figuring how many 4s go into 13 evenly and how many fourths are left over. Hope this helps. Thanks so much.